Hi everyone, this is Mrs. G, and today we're going to be solving radical equations. So I have a quick warm-up for you guys, so please pause the video and give these two a try, and we'll check your answers in just a few moments. Alright, go ahead and check your work. So here you need to do 2 steps to isolate x to the fourth, and then here you'll take the plus or minus fourth root of both sides. Please don't forget the plus or minus. You need to include it anytime you're taking an even root of both sides. So you actually have 2 solutions, plus or minus 2. And then for part B, if you multiply both sides by 2, you're isolated. So take the cube root of both sides, and the cube root of negative 64 is negative 4. Alright, so first we're going to talk about how to solve square root equations. So if you have a square root equation, your first step, just like when we were solving equations with powers, is to isolate. But this time you're going to isolate your radical. Then to clear your square root, we're going to square both sides of the equation. And then sometimes we will need to finish solving if necessary. For square root equations, it is extremely important that we check all solutions. Since square root functions have a restricted domain, is not all real numbers, sometimes we get what are called extraneous solutions. So those are when you're doing all of your math correctly, you get this number that should be an answer, but when you plug it into your equation, it doesn't work. So again, that's called an extraneous solution. And again, the only way to know if you have one is if you check your solutions at the end. So please don't forget this step. Alright, so we're going to try 2 examples together. We're going to solve, and it even says, don't forget to check your solutions. So here, again, our first goal is going to be to isolate this square root of x plus 10. And we can do that by subtracting 2 from each side. So that leaves us with the square root of x plus 10 equals x minus 2. So now, to clear my square root, I can square both sides. Notice I'm putting parentheses around the entire side and squaring it. I need to do this on the other side as well. And I want to remind you, you cannot distribute exponents when there's a sum or difference. We will need to actually multiply this out. So on the left, the square and the square root cancel each other out, leaving us with x plus 10. But on the right, again, x minus 2 squared means x minus 2 times x minus 2. So now, to finish solving, we will need to multiply this out. So we get x squared, and then we get minus 2x, which is minus 4x, and then plus 4. So you can see this is a quadratic equation, so here's a really good review for solving. We should always start by setting our equation to 0. So I'm going to subtract x from each side and subtract 10 from each side. So we get 0 equals x squared minus 5x minus 6. And here you can solve this in a number of different ways. For me, if the equation is factorable, that's always going to be the method that I use. But of course, quadratic formula should always work. So this one is factorable. So it's going to be x minus 6 times x plus 1. So this gives us 2 solutions. So when we do zero product property, we get x minus 6 equals 0. So x equals positive 6. And we get x plus 1 equals 0, which gives us x equals negative 1. But remember, we might have what's called the extraneous solution. So we do need to check our answers. So the way we check, I'll put this on the side, is by substituting our potential answers into our original equation to see if it works. So let's start by first checking x equals 6. So again, we're going to substitute it. So we get 2 plus the square root of 6 plus 10 should equal 6. So again, we're going to see if the left side of the equation equals the right side. So 2 plus the square root of 16 equals 6. 2 plus 4 equals 6. Okay, 6 equals 6. So that checks out. So that means that x equals 6 is a solution. So now I can box it. And now let's check x equals negative 1. So we have 2 plus the square root of negative 1 plus 10 equals negative 1. So 2 plus the square root of 9 equals negative 1. So this is claiming that 2 plus 3 equals negative 1. We know that 5 does not equal negative 1. So that means that x equals negative 1 is actually an extraneous solution. So although we did all of our math correctly, our quadratic equation was solved correctly, and we got this as an answer, it does not work for this radical equation. So make sure you cross it out, do not box it. It is not one of our solutions. This equation only has one answer, x equals 6. All right, here we're going to try one more problem together. So this might not look like a square root equation, but remember, if you have a rational exponent, we can rewrite it as a radical. So this is actually, we can rewrite as the square root of x plus 6. So remember, this becomes our inside exponent. This becomes our index, so it is a square root, minus the square root of 2x minus 4 equals 0. So this one is a little bit different because we actually have two separate radicals. So when possible, when you have a case like this, we can kind of isolate them by moving them to separate sides. So then imagine I take my second radical, and I'm going to move the whole thing to the other side. So then they are isolated on separate sides of our equal sign. So we have the square root of x plus 6 equals the square root of 2x minus 4. So now that we've done that, we can clear our square roots by squaring both sides. And that gives us x plus 6 equals 2x minus 4. And then to finish solving, we can subtract x from each side and add 4 to each side. And that leaves us with x equals 10. So again, before I box it, we do need to check our solutions. I'm going to check using this equation, this form of the equation, because it means the same thing as our original equation. So here's our check. So again, we are going to substitute it into the equation. So the square root of 10 plus 6 minus the square root of 2 times 10 minus 4 equals 0. So this says the square root of 16 minus the square root of 16 equals 0. 0 equals 0. So this does check out, which means that x equals 10 is a valid solution. All right, so now it's your turn to try one on your own. Please pause the video and give this problem a try, and then when you're ready to check your work, hit play. All right, go ahead and check your work here. So again, anytime you have an exponent that's 1/2, it is actually a square root. So I rewrote it, and then you can isolate your square root and then square both sides. And when you finish solving, you should get x equals 4. But before I boxed this number, I checked it. So I plugged it into this form of the equation to make sure that the left side actually equaled the right side, which it did. So this is a valid answer. All right, so now we're going to move on to solving cube root equations. So similar process, we are going to start by isolating our radical, but this time we're going to cube both sides of the equation to clear the cube root. And then of course finish solving with if necessary. The nice thing about these problems is that you do not need to check your solutions. If you have an odd root equation, so a cube root or a fifth root, or anything with an odd index, you don't need to check because those types of functions have a domain which is all real numbers, which means any answer should work. All right, so we're going to try 2 together. Let's look at example A first. So again, we do need to start by isolating our radical. So I'm going to subtract 7 from each side. So we get the cube root of x plus 2 equals -2. And then to clear my cube root, we can cube both sides. And that leaves us with x plus 2 equals -8. And then last step to finish solving, subtract 2 from each side, and we get x equals -10. Now, if you wanted to substitute this into your equation, you could, just to see if your answer was correct. But again, we don't have to check it. We shouldn't be getting any extraneous solutions with cube root equations. All right, let's have a look at example B. So again, our radical has already been isolated, so now we can cube both sides. So we're going to put parentheses and cube it. And please note that we're cubing the entire side. So we do need to put parentheses around it and cube it. And please remember, we cannot distribute exponents when it's a sum or a difference. So on the left, we get x minus 5. The cube and the cube root cancel out. But on the right, this actually is x plus 1 times x plus 1 times x plus 1. So here, we actually do need to multiply this out to solve. So when we're multiplying something like this out, we can start just by multiplying 2 of them together. So this x plus 1, we'll keep it out front. And then when I multiply these, we get x squared. And then plus 1x plus 1x, so that's plus 2x. And then plus 1. And then we're going to need to multiply this binomial to the trinomial. So this leaves us with x cubed plus 2x squared plus x. So that's my first term multiplied to each of the terms. And then plus x squared plus 2x plus 1. So again, my second term multiplied to all 3. And now we can start combining like terms, and we should set our equation equal to 0. So let's combine like terms first. So we get x cubed, and then here I have 2x squared plus x squared, which is 3x squared. And then here I have x plus 2x, which is 3x plus 1. And then let's set our equation to 0. So I'm going to subtract x from each side and add 5 to each side. So we get 0 equals x cubed plus 3x squared plus 2x plus 6. So here, to solve this one, we can try factoring it. Since there's 4 terms, I'm going to try factor by grouping. So we start by looking at our first 2 terms, and we see what their GCF is. So this has a GCF of x squared. And then our second 2 terms have a GCF of 2. So let's see what we get. So this gives us x squared times x plus 3 plus 2 times x plus 3. So since we see a common factor here, we can group these into their own factor. So we get 0 equals x squared plus 2 times x plus 3. So from here, when we do our 0 product property, let's see what we get. So x squared plus 2 equals 0, x squared equals -2. It's impossible to square a number and get a negative answer, so this is know a solution from this factor. So this factor doesn't tell us a solution. However, from the other factor, we can solve and we get x equals -3. And again, if you're ever unsure, you can plug this into the original equation to double check. So if we did that, looking back up to the top, we would get the cube root of -3 minus 5 should equal -3 plus 1. So this is the cube root of -8 equals -2, and -2 does equal -2. So again, you don't have to check your answer for cube root equations because you shouldn't get any extraneous solutions. But again, it's always good to check your answer, especially if you have time to do so. So there you have it. Alright, so here's the last problem of the video. Please pause the video and try this on your own, and then we'll check your answers in just a few seconds. Alright, go ahead and check your work. So again, anytime you have something raised to the power of 1/3, that's a cube root. This is a cube root equation, and so isolate your radical, cube both sides, and then finish solving. Again, since we are, this is a cube root equation, we do not need to check our answer for extraneous solutions, but you absolutely can to check that it is correct. Alright, that's all for today's video. Thank you so much for watching.